Shh. 5, 4, 3, 2, 1. Here we go. Okay. So today we introduce logarithms. Some of you guys have seen them before. Some of you have not. The common statement from people, even after this unit, is I still don't know what a logarithm is. Visit with people in the science department or even the math department. They say, I don't remember anything about logarithms. This is the lesson I would ask that they come and attend. I've actually invited people in our staff to say, come and observe and learn logarithms again. And when you learn things a second time, it's easier, isn't it? Yeah, when you see it a second time, it's not as bad. So already you're remembering a little bit that we did last year. Okay, yep, and so that's going to kind of help you out. But log base a of x means, what it means is a base of a raised to some power is equal to x. Now we're going to give you a number of times during this day to be able to understand a logarithm and understand its importance. But let us begin by taking something that is in logarithmic form and writing it in exponential form. So I often ask people, they say, I don't know what a logarithm is. And I say, do you know what an exponential is? And they say, yes. I'm like, well, then you probably do know what a logarithm is. You see, this can be written in exponential form. This says log base 2 of 32 is 5. This is the base, so it's 2. And the exponent is what logarithms solve for. So it's 2 to the 5th is equal to 32. These two expressions are synonymous. They mean the same thing. Good with that? Okay. All right. So the next one, how would you write this in exponential form? And it should make sense to you. For example, suppose that you mix something up and you wrote 6 to the 36 is equal to 2. Please tell me that if you wrote that down, like that would be challenging for you to finish that because your brain would be saying, no, I know that that's not true, is it? It's not true at all. So you don't want to write a statement that is not correct, okay? So what would letter C be? 12 to the 0 is equal to 1. We know that anything to the 0 power is equal to 1. We talked about that yesterday, did we not? And this would be 3 to the 4th power is 343. Oh, yes, I'm sorry, 3 to the 5th. I hit the 4th key by accident when I was printing these. Sorry about that. 3 to the 5th. What's different about letter E and F? Yeah, it has the letter E and it has ln. So let me tell you what ln means. ln means natural logarithm, but it's a French word, and they put the adjective after the noun. So when they would write it in French, it would be logarithme naturel. Okay, and so you can see in French why they would put it as ln, right? So we say natural logarithm, we reverse it, so we're like, why isn't it NL? Well, that's because English wasn't the language that was denoted with. So we've got natural logarithm. Now, anytime you have the natural logarithm, that is a log with a base of e. It's a log with a base of e. So this means log base e of e is equal to 1. Okay, so you see the e, you see the equals, and you see the 1 right there. So this ln just means log base e. Okay, so you would write this as a base of e to what power? 1 is equal to e. Does it make sense that e to the 1st is e? Good. Now you don't need to rewrite it every single time. Okay, so like here, I'm not going to rewrite it. What is the base? E. What's the exponent? 0 is equal to 1. Excellent. You see that? Good, good, good. Okay. All right. So, help you just understand a little bit. What operation goes with addition? Addition and subtraction, because you use one to kind of cancel the other out, right? If you had to choose whether you're going to add or subtract, what would you choose to do? Mikey, would you rather add or subtract? You'd rather add. And if I say multiply, you would also say divide. If I gave you a choice, Lily, whether you're going to multiply or divide, you would rather. Your brains are naturally wired to want to do those things. they're not as naturally wired to do those things. Okay, that's factual. We see evidence in nature that these things happen more easily and these don't. It's the same that's true with exponentials. So would you rather do 4 squared is equal to 16 or log base 4 of 16 is equal to 2? We all agree that we prefer that, right? That's because you're wired more that way. Do you understand? But this is useful, just like division and subtraction have to be used sometimes, right? Okay, so let's do the opposite. Let's take these in exponential form and write them as logarithms. This would be the log base what?
2.
Of what?
16.
16 is equal to 4. So what I always think of is it's easy to figure out where the base goes. I think logarithms solve for exponents. So exponents always go on the end. This would be log base 10 of 100,000 is equal to 5. Now, it's also true that the assumed base of a logarithm is 10. So you don't have to write log 10. If you do, I mark it correct, but it's also correct and more customary to write it as log of 100,000 is equal to 5. Take out your calculator. Your calculator is equipped, and I know it doesn't seem like a big deal now, but there are teachers here who remember in school not having a calculator that had some of these operations. So for your calculator to have an operation of logarithm or natural logarithm, or for it to have sine, cosine, tangent, that's a big deal. There's some immense amount of mathematics and calculus that goes in to being able to come up with something with those buttons. So why those buttons give you the numbers that they do, it's pretty amazing. Let's show you how to use them. Log of 100,000. Log of 100,000. You just type it in, okay? And we know that that should give you 5. No big deal, right? Notice that when you press log, again, the assumed base is 10, okay? Now, suppose it changes. Suppose that it is a base of e. Natural log of e is 1. I'll show you the natural log spot. That's ln right here. It's next to the 4. So I press ln, and then e is right above the division sign. So second divide, that's the e, and that should be equal to 1. And you see that that expression is true. See the logarithm features on your calculator? So now I'm going to try to confuse you momentarily to see if you can make some sense of this. I want you to think about this. 10 to what power is equal to 200? Talk to your peers, see if you can think that through. Go. Let's talk about it here for just a second. Okay, what is 10 to the first power? 10. What's 10 to the second power? 100. What's 10 to the third? 1,000. So wouldn't you agree it would have to be between 2 and 3? It just so happens that the answer to this is the logarithm of 200. If you take the logarithm of 200, you get 2.301. So if I took 10 and I raised it to the 2.300102, we'll just go 9, and I press enter, it's going to give me a value very close to 200, isn't it? So you can see that I was able to ask you guys a problem that all of a sudden confused us a little bit, didn't it? But see how logarithms make it simple? And that's what we're eventually going to teach you, is how to solve complicated problems using exponentials and logarithms. As long as you follow this basis, you'll be fine along the way. So that's the importance of it. Let's continue to rewrite here. This would be log base what? 8 of 1/64 is equal to -2. log base of 1 is equal to 0. Yep. Remember, the exponent always goes on the end. Log base 10, I don't have to write the 10, I can leave it off, of 1/10 is equal to -1. And since the base is e, I write natural log of e is equal to 1. Any questions about the basics of the logarithmic expressions? Okay, please flip it over. Okay, it says evaluate the following expressions. I would like to know what the log base 4 of 64 is. So when you're trying to think about something, you might try to write it as, that means 4 to what power is 64, right? Isn't that what that means? So therefore, log base 4 of 64 is, it is 3. And then this, log base 3 of 1/9, that means 3 to what power is 1/9? Yep, so 3 to what power is 9? So 3 to what power would be 1/9? -2, so this answer is -2. And this one says 8 to what power is 8 to the first? 8. Everybody see that? Oh, I'm sorry. I wrote. I'm sorry. I was thinking about the next problem. 1. Yep. Sorry about that. Sorry about that. I was trying to anticipate where we were going next. Can people understand that letters D and E and F, that those don't look quite as simple as those first few did they? So now it's time for me to teach you. This is probably the most important part of the next number of days that you learn this operation. And what I'm going to do is I'm actually going to rewrite these. You don't have to, but I need to do this in order to make a point. And so I'm going to rewrite this. I'm going to write log base 4. Does everybody agree that 64 is 4 cubed? Yes? And then I'm going to rewrite this, log base 3. Everybody agree that 1/9 is 3 to the -2? And then this is log base 8 of 8 to the first power. So I'm going to keep that there, and we are going to flip back a page to write down the next part of our notes that we need. Okay? Okay, maybe you noticed when we started our notes, we didn't fill out those two pieces. That's what we're going to start using now. Those are super important. I told you that addition and subtraction go together, agreed? And when you're solving an equation, those actually work in conjunction with each other, don't they? And multiplication and division work, right? So if you have 2x minus 1 is equal to 5, you are going to add 1 to both sides because addition and subtraction make each other go away, right? You get 2x is equal to 6. And how do I get rid of multiplication? I divide. And so you can see that these are operations that undo each other, don't they? And we've learned actually in this class that there's other operations that undo each other. Remember that we taught you f inverse of f of x? Remember we taught you how to compose these different functions? And actually, if you remember this, when we composed these, those went away and you were just left with x. And so it also works that logarithms and exponentials are inverses. They undo each other. So if you see log base a of a, these cancel and leave you with just x. I know that looks ridiculous. I know that may even seem wrong, but that's what happens. Then if you have a to the log base a of x, these go away, leaving you with just x. So let's see how we can use that as we flip it over to this side. I'm going to do these same problems to try to make a point for you. You don't have to redo them. I just want you to see log base 4 of 4 to the third. What's going to go away? And I'm left with 3. These go away. I'm left with -2. These go away, and I'm left with 1. So if you look at this, log base 5 of 5 to the x plus y, these go away and leave you with x plus y, because they are inverse operations. And then 3 to the log base 3 of 7, those are going to cancel, giving you 7. Those are straight from the ACT, folks. Natural log of 1 over e squared. I'm going to rewrite this as the natural log of e to what power? 1 over e squared is e to what power? -2. Okay? What is the base of a natural log? E. So therefore, natural log and e cancel each other, giving you -2. Now, sometimes it's not that easy. These next 3 are straight from the ACT as well. I'm going to do these first 2 with you, and then after that, you're going to try the third one on your own. Worked pretty well first hour. We'll see how it goes here. Okay? Log base 4 of 8. That means 4 to some power is equal to 8. Well, 4 to the 1 power is 4, and 4 to the second power is... So it's got to be somewhere between 1 and 2, right? Let's try to figure it out. And the best way to solve this is to create a common base. 4 and 8 both can be written as a common base. What number powers to both 4 and 8? 2. 2 to what power? 2 squared is 4, right? So this becomes 2 to the 2x. And 8 can be rewritten as 2 to the third. Now this is easy. If the bases are the same, then the exponent should be the same. Okay, if we're going to solve it, now the bases are the same, we just solve 2x equals 3. So what is x? 3/2 or 1.5. We said it was going to be between 1 and 2. Look at the next one here. What's the base? 10. So this is 10 to what power is equal to the square root of, what number is that? Let's see, 1/10th, 100th, 1,000th, 1/10,000, 1/100,000th. We got that? So square root of 1/100,000th. Okay, I have a base of 10 over here. I'd like to get a base of 10 over here. Square root means to what power? Close, 1/2. You okay with that? And then 1 over 100,000, that would be, so I have 10 to the x is equal to 10 to what power? What 1 over 100,000 is 10 to what power? -5. Whoops, sorry about that. Yep. And if I have a power to a power, what do? I multiply. So I have 10 to the x is equal to 10 to the -5/2. So what is x? -5/2. Try letter on your eye on your own. Try anything straight from the ACT. See what you can do with it. Try. Try something. Go. Okay, why don't you pause and glance and see about where you're at. I have 2 to some power, so 2 to the x power is equal 4 to the 1/3. Did you write that? Yep. Okay. And then 4 is the same as what? 2 squared. So 2 to the x power is 2 squared to the 1/3. I can multiply those, and I get 2 to the x is equal to 2 to the 2/3. So we want to solve for x. What would x be? 2/3. You got it? Good. Yes. Cubed root means 1/3. Fourth root means 1/4. Better? Okay. We're going to do this last set here, and then you guys are going to have some time to work, and we'll pick up the rest tomorrow. Now we want to look at logarithmic expressions, and we just, again, want to try to challenge your mind to think a little bit differently than it has. But we're going to move x around into different spots. So I'd like to know what number goes there. Anybody know what number goes there for x? Let's try rewriting it. It is 8. This would be 2 to the 3rd power is equal to x. So if you're having trouble understanding a logarithm, think of the exponential. So what is x? X is 8. Go ahead and try B and C on your own. Sorry, I erased some of that stuff.
So there shouldn't be a 3 right there?
No, because there's still it's just 2 to the x. So 2 to the x or 2 to the x.
Oh, we're just rewriting this.
Yes.
We're not, okay.
Yep. I've got 10 and 3. Everybody good to go with those? Okay. All right, let's try the last 3 together. When I first see this one, I think of 1/2, which is square root, right? And I see 49. Anybody know what number I come up with? I come up with 7, but 7's not right. So make sure you think about it, work it out. The base is x. The power is 1/2 is equal to 49. That means what number did you take the square root of to get 49? Does everybody agree that the square root of 7 is not 49? What would you need to do to both sides to solve? Square both sides. And you get x is equal to 49 squared, which is 2,401. Yep. So be careful to make sure that you're working the problem through. The next one, very interesting question here. Log base 2 of 0 is equal to something. What is it equal to? Well, if you put x here, sure. So that means 2 to what power is 0? Well, 2 to the 0 is 1. 2 to the negative 1 is 1/2. It is undefined. Why? Why? Shh. Let's take you back to just yesterday so you can connect this. Do you know what the graph of 2 to the x looks like? We just did it yesterday. Looks like this, right? So it goes through the coordinate 0, 1. So you're wondering, when is this graph ever equal to 0? Does it ever touch the x-axis? No. An exponential can never be equal to 0 in this way. So there is no solution. That should convince you. The next one, this would be 10 to the negative 3rd is equal to x. What is x? Very good. Please take out your homework. Yes.
Two questions.
All right, your homework from 4.2 is this, okay? You're going to start working on the front side. If you flip it over, you can see that section 4 is similar to what we just did. But then section 5 and 6, it starts talking about graphing. That's what we're going to get to tomorrow. So you don't have to do section 5 and 6 right now, but the others you should do. I want to be clear that some of the problems can be challenging. It would be very strange if all of you were able to come to class and not have any questions on the assignment that you just received. If you knew how to do every single problem and none of you had any questions, that would be very strange. Most of you will have questions on at least 2 or 3 of these. So don't feel bad if we got to ask a question at the beginning of class tomorrow. We good? You guys got a nice 7 minutes. See what you can get done. Give yourself plenty of time on the roads today. Be safe, be smart, and we'll see you tomorrow.